Hello everyone, this is the last part of chapter 3 that we will be due this week. Can I remind you that you have till midnight Sunday, excuse me, to midnight Sunday to complete all your homework assignments, and I believe it's going to be late on Thursday, your first test will become visible. So that's your online test 1. Also has to be completed by midnight Sunday. So I strongly suggest that you make sure that you do the homework first and you spend as much time as you can just reviewing it so that you're ready for your first test. When you click on the online test 1, it is timed. So the minute you click on it, you will have exactly 2 hours to complete it. And I also should ask you to bear in mind that it's a good idea to submit answers each time. Don't wait until you've done all of them and submit all, because you may get caught out with the time and nothing gets saved, and that would be bad news for you. So you don't want to do that. So as you go through the online test 1, each question you should be able to submit answer. You're allowed 5 answers to every question. What makes it different from homework is that it will not tell you if you're correct or wrong. So you're going to have to, make sure that you're correct, and if you're comfortable with your answer, then you just move on. So you won't get the same feedback until after the test is finished, and sometime in Monday, I will release the grades. And you will then be able to return back to the online test and see what you did wrong. And it should give you some help so that you can maybe repair any mistakes that you've got and be ready next time those questions appear. But for right now, let's focus on the last assignment. We're looking at chapter 3, slopes and y-intercepts of a line. And the first thing that we're going to be looking at are questions 1 to 6 in the homework are like this, where you've been asked to find the slope of a line and you're given the coordinates of 2 points. So let's just show you what the slope of a line looks like. Remind you, essentially. Suppose I have a point here, we call it P, and its coordinates are 1, 2. And I have another point. I'm going to call it Q because I prefer Q, and it is 7, 6. Now the slope of a line, we typically use the letter M to represent it. It can be found by calculating what's called the rise over the run. So in this question here, what you do is you imagine a vertical line going down the way and a horizontal line going across, and they will meet there. And the distance from here to here is called the rise. And the distance from here to here, that's called the run. Now, as long as the coordinates of the points are reasonably small, you could actually draw a picture like this and just count the boxes. So can you trust me that the distance from here to here would be 5, and the distance from here to here would be 6. And so the rise over run would be 5 over 6. And that is a positive fraction. Now, the bigger the slope is, the steeper the line is. So that pen right now might have a slope of 5. Right now, it's probably got a slope of about 1/2. And you can imagine if it gets shallower, it might have a slope of 1/20. Eventually, you end up with a horizontal line if you keep going that way. And a horizontal line is quite interesting because all horizontal lines have the same slope. And the slope of a horizontal line is 0. Now, if you take that line and its slope is 5, 6, as you go up, it becomes maybe 2, and then it becomes 10, and then it becomes 100 and 1,000,000, and it becomes really big. Eventually, it becomes vertical. And vertical lines, they are also very interesting, but their slope is undefined. Essentially, their slope is infinite. They go infinitely vertical, right? They don't go across the way at all, right? They go straight up and nothing else. Now, there are other kinds of slopes. Line like the one I've just drawn has a positive slope of 5, 6. But you can have lines that point that way. And what you will find when you have lines where they go from here to here, basically downhill. I think of uphill and downhill as if you were traveling from left to right, this is downhill. And as you travel from left to right, this is uphill. Uphill generates positive slopes. Downhill generates negative slopes. So that might have a slope of -1 or -7/8 or something. So negative slopes can happen, positive slopes can happen. When you've got a horizontal line, the slope is 0. And when you have a vertical line, the slope is described as undefined. And when you get a homework question and it's undefined, I believe you type in capitals undefined. So everything is capital U, capital N. Just do that to keep WebAssign happy, because I'm not sure if you wrote it as little case, it might not recognize that as an answer. Well, if the 2 points are reasonably small numbers, you could plot it and get the answer by just counting boxes, but that's really quite impractical. So there is actually a formula for calculating the slope. So let's show you what that is. So here it goes. The formula for calculating the slope. And let's assume that we've got 2 points, we'll call them x1, y1, and the other point, let's call it P2, and it's going to have the coordinates x2, y2. Then the slope, which we're going to use the letter m to represent, is given by this fraction. y2 take away y1. That's essentially the difference in the y coordinates, which corresponds to that number there, the rise. And you divide it by x2 take away x1, which is essentially distance from here to here. We call that the run. So that is the equation that you can use. Now, the advantage of this is that you can do it with large, cumbersome numbers. You can even do it with fractions. So if any of these values, x or y, are negative or really big or small or 3/4, this formula will take care of it with a little help from your calculator. So as an example, suppose we have P1 with coordinates -1, 2, and P2 with coordinates 5, -8. And I would like to know the slope from P1 to P2. So this guy is going to be called x1, y1. This guy is going to be x2, y2. The slope is going to be y2 take away y1 all over x2 take away x1. So that's going to be -8 take away 2. So -8 subtract 2. And on the bottom, 5 subtract -1. The top two give you -10, and 5 subtract -1 is 5 add-on, so you get 6. And this simplifies down to -5/3. And that's the answer to the slope of the line joining these 2 points. So let's try another example of that, just so we can go practice. Let's suppose that P1 was the point 2, -10, and P2 was the point 5, -3. I'll call that guy x1, y1. I'll call this guy x2, y2. And now I'll calculate the slope by using our formula. Right. So it's going to be y2 take away y1 all over x2 take away x1. And that's going to be -3 subtract -10. And on the bottom, it's going to be 5 take away 2. Now, -10 subtract, sorry, -3 subtract -10 is actually -3 add 10, which gets you 7. And 5 take away 2 is 3. And so the answer is 7/3. Now, if I wanted to double check that or actually just do it on calculator, this is what it would look like. You do a bracket. Then you do -3 subtract -10. Then you divide another bracket, 5 take away 2. You get that. And then you do math, turn me into a fraction, and you see the answer is 7/3. So you could actually do most of that by using the calculator. So here is our answer to the slope joining these 2 points. So let's look at some special cases and then we'll pretty much finish this. Suppose I had 3, 5, and the other point was 3, 7. So we'll call that x1, y1 is always. We'll call this x2, y2. Again, pretty standard. Our formula for calculating the slope is that. Now let's see what that gets us. Well, I guess I should do it down here. It's 7 take away 5. And then it's 3 take away 3. Now that's not a nice result. That calculation has a problem. It's quite a big problem. You cannot divide anything by 0 and get a meaningful numerical answer at least. So this is undefined. Now I mentioned earlier when you got lines who were undefined. And it happens when they're vertical. Now, if you plot the point 3, 5, and then you plot the point 3, 7, and I'll do a little baby version of it. You can imagine that's 3 and this is 5. There's the first one. And imagine that's 7. Can you see the second one? Can you see that what you get is a vertical line? It makes perfect sense that you would get an undefined slope, essentially an infinite slope, when you do a division by 0. Right, so that's essentially the x's equal to each other, so they get you 0. So that's a special case. Sometimes the slope is undefined. And the other special case would look something like this. Imagine you wanted to find the slope between -3, 4 and 5, 4. Now you might already kind of guess what's going to happen here, but we're going through the math to see what the result looks like. So the slope joining these two is going to be the difference in the y coordinates over the difference in the x coordinates. And that's going to get you 4 take away 4 and 5 take away -3. And that's going to get you a 0 on the top, and 5 add 3 gets you 8. Now that is not a problem. That is actually something I can calculate. It's equal to 0. And 0 slopes are horizontal lines. And if you plotted those 2 points and you joined them, I bet you'd find a horizontal line. So there is your answer. Here is the answer to that situation. And that pretty much is our first topic in this section. How to find the slope of a line containing 2 points. And the first 6 questions of your homework are going to be very similar to what we just covered. So I'm now going to move. Let me just pause here. Okay. I was just making sure that my camera was working. I hate this to continue and find out at the end that none of it is registered. Right, so the second thing we're going to do is how to find the slope and the y-intercept from the equation of a line. So if you can imagine a straight line, let's say this line here, and let's just say for argument's sake that it's 3x plus 1. The y-intercept is that point there. So that guy there is the y-intercept. And you can imagine what the slope of that line would be like. You could pick 2 points on it, I guess, and do this and do that. And you'd get the rise and you'd get the run. And we could, from the equation of a line, find both these things, the y-intercept and the slope. And it really depends on how the equation of the line is written, how you do that, because in one situation, it's actually very easy. So the first situation is when your equation is written in the y equals form, like 3x plus 1 here. And when that happens, this number here is called the coefficient of x, this 3, that's the slope. And this number here, plus 1, that is the y-intercept, or at least it's the y-coordinate of the y-intercept. So that's what the coordinate would be, 0, 1. That's how simple it is. As long as the equation is written as y equals, you can find the slope, okay, which is 3, and the y-intercept, which is this guy. And there are 3 questions, 7, 8, and 9, where you get to do that. So let's show you an example of that. This is a version of question 7. And y is -3/4 x plus 7. And we're just being asked to find the slope. We'll put the answer in that box. And the coordinates of the y-intercept. It looks something like this. Okay. The number, in this case, the fraction next to x, the coefficient of x, is your slope. And this guy here is the y-intercept, and its coordinates, because that's the y-coordinate of the y-intercept, is 0, 7. So you put 0 and 7. So, I mean, that's a really pretty straightforward, in my opinion, question. If I give the equation of a line and it's written as so many x plus or minus a number next to the x, we call that the coefficient of x, will be the slope. And this term here, which is called the constant, in this case it's plus 7, will give you a y-intercept of 0, plus 7. So the only other version of that question is a little bit trickier, because what they do is that they can give you the equation of the line, and it's a bit jumbled up. So it might be something like this: 3x plus 2y equals, let's say, 18. Now, I still want to find the slope and the y-intercept, but it's not written in the format that this one is, right? It's written in its standard form. So what we have to do is essentially change this equation so it looks like this one. So I'm going to do, as long as you do it to both sides, it's okay rule. And the first thing I'm going to do to both sides is subtract 3x. And then I'm going to divide both sides by 2. So I'm dividing that guy by 2 and that guy by 2. I now know the slope. The slope is -3 halves. And I know the y-intercept. The y-intercept is 9, or its coordinates are 0, 9. And that's pretty much the end of those 3 questions. So if you're given the equation of a line and it's written as y equals so many x's plus a number, the coefficient of x is the slope, this constant term, the number that's left over, will allow you to get the y-intercept. If, however, they give you the equation in its standard form, you need to rewrite it so that it becomes y equals. And you do that by using the technique, as long as you do it to both sides, it's okay rule. And that's what I've did here. And once you've got it into the y equals format, the coefficient of x will be the slope, and the constant, the number that's left over, will give you the y-intercept. And that gets us through 7, 8, and 9. So we're now on to our third topic. And we're going to look at how to graph a linear function using its slope and its y-intercept. And that's going to start, I believe, at question 10. So imagine I give you the equation of a line and I tell you that it's 2x plus 3. And I would like to use that to help me draw or graph, as we would call it, that particular line. Well, this equation is pretty much good to go. Would you agree that the slope is 2 and that the y-intercept is at 0,3? So what you would do is you would plot the y-intercept first. Now, if someone tells you that the slope is 2, and I want you to think of that as rise over run, then all you need to do when the slope is 2 is to think of it as 2 over 1. So you rise 2 boxes for every one that you go along, and there's your second point. And then you draw the line through the y-intercept and that second point. And if I draw a little extra invisible dotted lines, can you see a rise of 2 for a run of 1? From there to there would only be 1 box. So that's the trick to doing that. So I'm now going to move over and show you some really ugly versions of that same question. So this is us looking at a version of question 10 from your homework. So it's this guy here. Now, I can tell the slope is going to be 5/6, and I know that the y-intercept is -2. So I'm going to put in the y-intercept first, which is there. Now, 5/6, rise of 5, run of 6. So 1, 2, 3, 4, a rise of 5, and 1, 2, 3, 4, 5, 6, a run of 6. And there you go. Now, if you count these boxes, 5 boxes up, that's the rise. 6 boxes, that's the run. And I know what that's about, but hopefully it's not interfering. And let's just check it. There you go. Now let's try the next one. Now it's got a negative slope, so that's going to involve a little bit more work. It's -1/5 plus 2. The y-intercept is 2, so it's going to cross the y-axis there. Oops. It's going to cross the y-axis there. Now, a rise of 1 and a run of 5. Well, we have to realize that it's a negative slope, so we have to accommodate that a little bit. So if you think about negative, that's really going to be pointing downwards. So what I'm going to do here is I'm simply going to say -1 is the rise, which is essentially going down 1 and then a run of 5. So I'm going to go negative. So down 1, the rise is 1, and 1, 2, 3, 4, 5. If you look at that guy, rise over run, you can see it's 1 by 5, but it's pointing downwards, so that's -1/5. And that guy goes there. And so I will do submit answer. Now, the next one, same idea. Now, this one is a little bit different. The equation is not written in the form that we need it to be if we're going to do a sketch of it, right? We're going to graph it. And so that's part of what we need to do. And I'm going to be showing that in a moment, how we tackle that information not written in the form that we really want it to be. But if you click on this guy, there's a video that you can watch, which will show you how they approach it. And they don't always do it the same way as me, and that's fine. In fact, it's a good idea to see other ways to do it, because maybe the way they explain it makes more sense or is easier for you to understand, in which case, use their method. So the question that we're dealing with is we're going to sketch, right, draw a graph of this linear function. But it's not in the format that it needs to be. It has to be written as y equals. So I'm going to solve this equation. I'm going to change it eventually into y equals. And as long as I do it to both sides, it's okay. So I'm going to subtract an x from both sides. And then I'm going to divide both sides by -7. That's a bit messy here. If you divide -x by -7, you get +1/7 x. If you divide +7 with -7, you get -1. So can you see that we now have a slope of 1/7 and a y-intercept with coordinates 0, -1. And this is what's going to help me sketch my function. So I'm now going to return to the guy that we had, which is this one. And I'm going to put in its y-intercept, which is, get it right here. No, I forgot to do that. Yeah. Here. And then the slope was 1/7. So it's a positive slope. It's going up the way. So 1 up and 7 along, right? A rise of 1 and a run of 7. And that actually takes me to here. And I should be able to submit my answer. We got it. And there's 14 is a very similar problem. And now we are kind of coming to the final topic, which is applications. And there's only a couple of these questions. So hopefully I can just use the graph and the information that's on it to answer it. Now the graph below shows how the altitude of an aircraft above the runway changes after takeoff. Okay, find the slope. So you imagine it's taking off and the altitude is what, in thousands of feet. So basically it's gliding upwards. That's okay. Find the slope of this line. Well, the nice thing is, haven't they told us 2 points on the line? And I'm going to use that to calculate the slope. And then I'm going to be, once I figured it out, I'm going to be really careful because of units. That 6 isn't 6 feet. That 6 is 6,000 feet, which means that 12 is 12,000 feet. This 5 is 5 minutes. This 10 is 10 minutes. So I have to be a little bit careful when we talk about the units. So here is our calculation. To find the slope, which is M, we're essentially taking a point whose coordinates might have been 5, 6, but they're really 5, 6,000. And the other one was 10, which is okay, 10 minutes. But the 12 is 12,000. So the slope is going to be y2 take away y1 over x2 take away x1. So that guy's going to be x1, y1, and this guy is going to be x2, y2. And that's going to get me 12,000 take away 6,000. And it's going to be divided by 10 take away 5. So it's going to be 6,000 over 5. In this case, I believe that is 1,000. What would that be? 1,200. And the units happen to be given to you. They are feet per minute. So this aircraft is climbing at a very, very steep rate, right? It's climbing at 1,200 feet per minute. And so the next part that you cannot see says, complete this sentence, telling us the meaning of the slope. And so the altitude of the plane is increasing at 1,200 feet per minute. And this slope here was 1,200. Right, now I'm now going to go back and show you what that looks like in WebAssign, which is that guy. So altitude 1,200. So submit answer. Am I good or am I good? Like that. Done. Now, the last question is question 16. And what it has here is a chemist is filling 2 cans from a faucet that releases water at constant rate. Can 1 has a diameter of 20 millimeters and can 2 has a diameter of 30. And the depth of water in each can is measured at 5 centimeter intervals. The graphs of the results are shown below on this picture, right? Which line represents the depth of the water? Now, let's read that again. On the graph, which line represents the depth of the water for which can? Should read this question again. The graph of the results is shown below. Check. Oh, okay, so I guess I have to figure out which one of these cans is the 20 millimeter one and which one of these cans is a 30 millimeter one. Now, if you have a big diameter, your depth of the water is going to rise slower, right? Because you have a big base and it takes more water to go up. So that means that A, because it's taking a lot longer for the water to increase in height, must be the big diameter. So I'm going to put in 30 millimeters here, maybe a gap. And I'm then going to put that one, and that's going to be 20 millimeters. And now I'm going to submit answer and hope I'm right. And I'm wrong. Oh, cool. So I'm not understanding this question. So let's read it again. He's filling 2 cans from a faucet that releases water at constant rate. Can 1 has this diameter and can 2 has that diameter. The depth of the water in each can is measured at 5-second intervals. The graph of the result is shown below. On the graph, which line represents the depth of the water for which can? Oh, so 20 millimeters is actually can 1. Okay, I got it. And that one goes there. So can 1 has 20 millimeters. That's the fast one, so that's B. And can 2, right, is, well, let's get this right. Right, can 1 is 20. 20 is narrower, 20 is fast, that's B. And so, yeah, and this is can A. You can tell it's the last question of the day. So let's do our little submit answer thing. Am I good? Am I good? Okay. I misidentified what I should have been calling it. I was kind of switching places. So the argument I gave at the beginning is correct. So let's see why that works. If you take can 2, for instance, right? Its diameter is 30 millimeters, right? So it's quite wide. So that means the water's going to rise quite slowly, which means it's A. And can 2, well, there I go again. Can 1 is going much quicker, and can 1 is B. So can 1, steep line, the water's going up really fast because it's a small diameter. That's B. And can 2, wider diameter, water's rising slower. And that is us for today. So just a last quick reminder, homework has to be done by midnight Sunday. Your online test 1 will appear sometime on Thursday. And remember that when you click on the online test, you have 2 hours to complete it. And so don't click on it until you're ready to do it. Okay, bye-bye. I will see you all on Monday, at least through the video. Bye-bye.